Good morning, and it's Wednesday, day 3. Your eating window today is going to be 4 hours, between 4 and 8. Remember, hydration is the key here. There's still people reporting headaches and tiredness, and hunger pangs. Dehydration. Hydration formula every morning. So in this video, we're going to talk about the health benefits of intermittent fasting. Although it's a fantastic, a fantastic weight loss tool, as you'll see and as you're noticing, and it's hopefully from an energy balance point of view now we start to understand why. We don't want to talk about the health benefits. Now, for me, the health benefits of intermittent fasting are fantastic, but they're also a bit common sense, and there's a big science behind this at the minute. Now, one of the most common health benefits that intermittent fasting is associated with, or any fasting, or long-term fasting, is a thing called autophagy, or autophagy, you might hear it being called. Now, what does autophagy mean? Autophagy actually means, it's the Greek words for to eat thyself. That's what it basically means, to eat yourself. Right. So what is autophagy and why is it beneficial? So understanding what we're talking about food consumption and insulin. So I eat food, specifically carbohydrates. And carbohydrates then broken down in the stomach, and the glucose or blood sugars. That glucose is released in the blood. When the blood glucose or blood sugar levels elevate, going hyperglycemic, the pancreas, the beta cells of the pancreas release insulin to go and tell the cells to open up and allow that energy to come in, so that whenever the sugar is absorbed out of the blood glucose number can come back down to baseline or back to normal. Once the muscle cells and the liver cells are full, any excess energy will be stored as fat. But the key thing here is insulin's being released, right? Right. When insulin is released, there's also a thing called IGF-1, which is insulin growth factor 1. And insulin growth factor 1, the giveaways in the name, makes things grow. Alright, the bodybuilders will actually inject IGF-1 to make the muscle bigger. So what does this mean? Now, they used to think that this was a good thing. Do you remember people said, eat small and often, right? 6 small meals a day. You're better grazing through the day than you are supposed to having 1 or 2 large meals, which is now, we realise now that was wrong. But the thinking behind that was you were getting multiple insulin spikes, therefore you were getting multiple IGF-1 spikes, therefore you were getting multiple growth spurts through the day. Now, when we look at cellular function, right, and again, I'll try and keep this as easy to understand as possible. When it comes to cellular function, your cells are always growing and maintaining and changing and moving. They reckon within 7 years there's a brand new you, because every cell in your body has renewed itself, from your liver, organs, all that kind of stuff, right? So think about a cell's constantly working. What they used to think would happen, or what the belief was, if this cell gets broken, right, let's say something happens to the cell, mutation. The reason why we get things like cancer is the cell starts to mutate. There's a certain function of the cell, they grow and move and produce energy and do all that kind of stuff. But with sort of like radiation and sort of solar radiation, stress factors, all those things, mutations start to happen. That mutation then can be cancerous and blah blah blah. So they thought that the cell repairing itself would be a good thing. So if you can supply it with like things like IGF-1, the cell can fix itself and grow. So this is called cellular repair. Alright, so the cell repairs itself. Now, I want you to imagine a part in your car, right? Even ladies, I'm sure you'll understand just this analogy. And it breaks, and you go to the garage and you just fix that part, and then you go and you drive away for a couple of months, and then the same part breaks, and you come back and he just fixes it. Doesn't do anything to it, doesn't add anything to it, he just fixes it. And you go away, it breaks, it comes back, and then all of a sudden, listen, that cell's just kaput, right? So the cell being not working right, it then starts to mutate, because it can't not repair itself anymore within the realms of it working well. Mutations, DNA mutations start to happen because the repair system's just not working anymore, and then it becomes cancerous, a cancerous mutated cell. Does that make sense? Right. So that's why we thought eating small regular meals was good for cellular function, because it provided with lots of energy, lots of growth, lots of reasons to repair itself and move on. And what does autophagy do? Remember, the term autophagy means to eat thyself. So what happens here, when we go bouts of time, before, again, there is multiple ways to induce autophagy, and autophagy can occur through multiple ways, and I'll give you some of them. But fasting was where it was basically discovered. So you're fasting, you've no food coming in, you've no insulin spikes, you've no IGF-1. Remember, you have to remember this. The human body is a survival machine. The reason why we evolved over 500,000 years and we outlived all our sort of species that were very similar to us, like the Denisovians and Neanderthals and all that kind of stuff, was because we are adaptation machines. We can adapt to any climate. If you look at any climate in the world, there's humans living there, and we're the only species that can do that. Most species are indigenously hot, cold, medium, whatever. We can live anywhere. We are basically adaptation machines. We adapt to stress, we survive, we move on. That's what we are very, very good at. That's how we evolved to be who we are. So we are adaptation machines. We adapt to stress to survive. In fact, most times we actually use stress as what we call adaptogens to be better and more resilient to move on. That's where the adaptation comes from. And also remember, through the whole of evolution, food is always hard to find. It's only in this modern last couple of 100 years that we have food in abundance. We're not used to living in this environment, right? We are hunter-gatherers. We're used to going out foraging for food, hunting for food, but also in that going long periods of time with no food, right? How do you survive with no food? If you need food for cellular function, especially if you need multiple bites of food through the day for cellular function. What happens here is the body goes, right, okay, I'm starving. I have no food coming in. So the difference between food coming in, food being stored, and food being available. So the body's very smart. The body will do like a self-diagnostic, a clean-up job. It'll go, right, you know what? I need fuel. I will use anything for fuel. I will use muscle. We talked about that. I'll use fat. It's actually known in times of real starvation, the body will actually start to digest its own internal organs. But what it does, it goes, right, if there's anything not working right here, if there's any cells that I think aren't really functioning properly, I'm going to take them, I'm going to eat them, I'm going to break them down for energy. Then what I will do is I will renew the cell. I will build a new cell from the ground up. So instead of constantly trying to fix this cell to the point which starts to become mutated, it sees the slight mutation come on, sees the cellular dysfunction, takes the cell, eats it up for energy, breaks it apart, and then rebuilds a new cell. So in the analogy of the car in the garage, you go to the garage, the boy says, that thing here is not working great, let's remove that and put in a new one. Chances are it's going to function a hell of a lot better. Right? Does that make sense? So that's autophagy. So when we go bouts of fasting, long bouts of fasting, we're talking about under the 20-hour fast, like what we're going to be doing today and tomorrow, right? And that 28, 22, 24 hours, we really start to induce autophagy because there's no insulin. There's no insulin, there's no IGF-1. There's actually people who have no IGF-1. There was a family of dwarfs, obviously they're going to be dwarfs because they have no IGF-1 from birth, but they are immune to cancer. We family of them, you can actually Google it, and they all smoke and they all drink and they all do the most unhealthiest of things, but they're immune to cancer. They have no cancer, right? So they've boiled this down to this IGF-1 growth factor because the cell just keeps wanting to grow and grow and grow and grow and repair and repair and repair and repair. So you see how it would make sense. Right, other things that induce autophagy. Resistance training. What are we doing when we're resistance training? The whole purpose of hypertrophy or hypertrophy training is we break down muscle fiber in the gym and rebuild new ones to make them bigger and stronger. Alright, so whenever you're training in the gym, if I'm say arm curls and I'm putting that muscle under stress, I'm lifting a big heavy load. By heavy load it means with respect to the individual. So for me, what's heavy for about 10 reps, I'm really struggling. What I'm actually doing at that point is I'm nipping muscle fibers. I am damaging muscle fibers. I'm not building muscle in the gym, I'm actually breaking muscle fibers down. I break down the muscle fibers, the body then uses protein and essential amino acids and fatty acids and hormonal functions like testosterone and estrogen and all that kind of stuff, and the rest and recuperation time to rebuild this cell to make it bigger and stronger. But I'm eating the cell, I'm breaking the cell down, I'm nipping the muscle fibers. I am in a state of autophagy, alright? Also catabolism, but it's autophagy. Saunas, long bouts in the sauna, excellent for autophagy. Right, so all those things induce autophagy, but Fasting is the easiest one you can do. Just don't fucking eat. Alright, again, we don't want to be doing this all the time. We spoke about this because there's survival and there's optimization of life. Alright, there's thriving and there's just surviving. So we want to use some of the tools that we've got to get fitter, to get stronger, to get leaner, to get healthier. Now, another great one here, especially for women in the menopause and men who are getting a wee bit older, things like arthritis, it reduces inflammation. How does it do this? Now, there's a bit of a mixed literature out there in the science-based sort of stuff. They reckon it's not really actually anything to do with fasting, but the abstaining from stuff. You have to remember we have omega-3 and omega-6, and that's your anti-inflammatory system at work here, right? So we should have a ratio in our diet of 1 to 1. 1 omega-3, 1 omega-6. So what happens is we fall, we bump our elbow, we damage it, omega-6 comes along and causes inflammation in that area to help heal it and protect it. Then omega-3 comes along with anti-inflammatory properties and removes inflammation so we can start moving again. Unfortunately, in the Western diet, because of processed foods and this and that and the other, and even things that you think are healthy, for example, salmon. If it's farm-fed salmon, it's very high in omega-6. Right, so we have a ratio of about 50 to 1 the wrong way. 50 to 1 omega-6 to omega-3. Which should be balanced or slightly above on the omega-3, on the anti-inflammatory sort of side of things. So if you're not eating any food, you're not consuming as much omega-6, right? So that's probably where they're getting some of that, the anti-inflammatory properties, but it's still anti-inflammatory, it still really helps. So if you wake up in the morning with aches and pains and the joints are a wee bit sore, fasting's great because it just stops the body from bringing all that stuff, like things like, you talk about cooking oils and grapeseed oils, they're all high in omega-6, they're all inflammatory, alright, so it's all inflammatory foods. Things like eating cream buns and all that kind of stuff, they're all cooked in the wrong oil, and unfortunately, even going to a restaurant quite regularly, they normally cook it in grapeseed oil, and the oils that are just very, you look into this a lovely plate of food, and I'm going to a really fancy restaurant, but it's doused and it's just really high in omega-6. So supplementing with omega-3 is also important, but those times with no food just means that you're not bringing anything in, and it makes perfect sense. All right, so it's good from that way as well too. Now, cognitive function is very good for your brain, all right, because what happens here when we start to fast, it's the same as going to a ketogenic diet. We're going to ketosis. Remember, the brain likes sugar. The brain uses a lot of your energy, but a massive percent of your energy today is used up by your brain. But the brain loves sugar because it's instant energy. Now, the only other thing that can get to the brain, because we've got what's called a blood-brain barrier, for energy, it's blood-brain barrier to stop toxins and poisons to get to the brain. But anyway, the blood-brain barrier, so only sugar can get up. Sugar gets up through the blood and gives it energy. But the brain also likes ketones. Now, how are ketones produced, or what is a ketogenic diet? So we talked about whenever we go on these stints of long bouts of no food, and there's no energy coming in, the body then has to resort to breaking down fat for fuel. Now, the fat will be used in two ways. One, it'll be broken down as, remember we talked about the triglycerides relating the fatty molecules in the bloodstream, go to the mitochondria. The mitochondria produces it for energy. But it can also be used to make, I don't want to say the word carbohydrates because it's glucose, but it's carbohydrates, right? If we're trying to simplify this. So the body will take fat, right, your fat cells, take it in the liver, and a process called gluconeogenesis. Now, I remember gluconeogenesis because I'm looking for glucose. Basically, sugar, carbohydrates is broken down to glucose. Glucose is then shuttled into the muscle via insulin, and inside the insulin is stored as glycogen. But the starting point is either carbohydrates that you eat or fat getting converted in the liver into glucose, getting converted to glucose, gluconeogenesis. Gluco meaning glucose, neo meaning new, and genesis means making something from something else, so gluconeogenesis. The byproduct of gluconeogenesis is ketone production. The liver produces ketones. Those ketones then go to the brain and give the brain energy. They're really good energy. Now, the thing about this is if we're relying on food, constantly relying on food for all our energy needs, our brain function needs, all that kind of stuff, then we're only really getting the energy as we eat, which is why we keep getting hunger in between them, or what we perceive as hunger in between them, and bouts of tiredness. Because if you're constantly relying on this insulin doing this here, when the insulin comes back down, because all the energy is getting stored, you're getting the I need food again, up, back up, down. But we go into this sort of fasted state, and we go into a state of ketosis, which is what we're looking for when we're fasting, which means the body then is utilizing the fat cells to convert that into fat for energy for your aerobic system, but also fat and the glucose for your anaerobic system. Now your anaerobic system, it's not going to be function at best. You're not going to go and lift the best weights possible, but you're still going to have muscle. That's why the muscles still move, because the muscles only move with glycogen, right? Glucose, sugar. So we're actually supplying both energy systems from our fat cells. This is why doing weights during your fasting time is fantastic, because we deplete the glycogen, and then we have to replenish the glycogen, but with no food coming in, so we've got to break down body fat, convert it in the liver by gluconeogenesis, back into glucosis, and then back into the muscle cell. Does that make sense? A byproduct is ketones, which go to the brain, hence the ketogenic diet, because the ketogenic diet is a diet that has fat and protein, but no carbohydrates. There is no such thing as an essential carbohydrate. Your body does not need carbohydrates. It will make it by itself through that process, right? So we have essential fatty acids because they're essential. You have to eat them. We have essential amino acids. They are essential because you have to eat them. The body can't make them. We do not have essential carbohydrates, because if your body can't eat carbs to get glucose, it'll make glucose from the fat cells. Does that make sense? This is why ketogenic diet is very popular, very good. I like keto, to be honest. I think I work really well with it. I don't work good with carbs. My weight session is actually better. Like, I'll squat heavier weight if I have no carbs in my system than I do if I have. Just the way my body functions, slows me down. I'm just normally very fat, and carbs just sit on me, so I don't like carbohydrates. I eat some, but I did keto for 10 years and I loved it. Right, so there's your option for trying to induce ketosis. So when we do that, we're not relying on these bouts of food, hunger and up and down and up in these waves of energy. We have this, right? Now we don't have this part, but we have this part. So sustainable energy through the day. So you shouldn't be getting those 11 o'clock or 3 o'clock energy slumps. You should be you feel great, you feel alert, cognitive functions very good. Again, for women in menopause that get that brain fog, ketones is fantastic. Now you can actually supplement with ketones. Personally, I don't like that idea, because ketones is a byproduct of gluconeogenesis. It's like saying taking the exhaust fumes out of a car is the same as the energy produced in the car. It's not. It's a byproduct, although the ketones do something for the brain, right? If that makes sense. So that's what some of the health benefits of this, and cognitive awareness, and why they're there. Why are they there? So for me, it's important to understand these things, because let's say you say, right, you know what, this autophagy thing sounds fucking good to me. That's anti-cancer. It's actually the fountain of youth, because even my skin cells are going to renew themselves rather than just repair themselves. I like the sound of this autophagy thing. So I'm going to try and do a 20 to 22 hour fast. Now in your head, you've now got motivation. It's not, oh Jesus, I'm going to die of hunger. I can't do this. Oh, I'm feeling faint. All this fucking stuff it used to do. Oh, I can't cope. But in your head, you're thinking, you know what, if I can push to this 20, 22 hours, I'm getting a lot of health benefits. I like the sound of this autophagy thing. I'm getting on in the years. For me, I'm 48. I'm looking at 50 and I'm thinking, what can I do in my life to make sure that I feel this way when I'm 60 and when I'm 70? And these wee bouts of sort of fasting really are going to give me good health benefits, as well as the health benefits that come from reducing your body fat, by the way. Right? But looking inside the body, what's actually going on, is really important to understand. It's very interesting as well too. If you have any more questions on this, let me know.